Hello everyone and welcome to part 7 on my series about vSphere with Tanzu on NSX-T. Today we are going to look at Kubernetes services. So a service is usually an abstraction which defines a logical set of pods and a policy by which init to access them. And normally these pods are targeted by a services are determined by a selector. So in the previous video we've created an Nginx deployment with a number of replicas. And we also included a selector, and we mentioned that it should match the labels app Nginx. We also attached metadata with the labels app Nginx. And we're going to use these labels as a selector when creating a service. So the deployment is already running. I will show now. So I'm logged in the alpha namespace right now. You can see 3 pods are currently running based on the deployment I'm showing above. And the service is defined very simple in this case. Just a kind service, which means the default type would be a cluster IP. Also attaching metadata, I give it a name and a label, and then a spec with regards to the ports I want to the service to listen to. So I want to cluster basically these Nginx pods using in the deployment using port 80. So the port is 80 and the target port would be 80. So I'm listening on port 80 and forwarding traffic to port 80. TCP, and then the selector would be app::Nginx. So this will be used to identify the endpoints to service the service 4, the cluster IP 4. So let's do first kubectl get pods -o wide. So again, these are the pods being run based on the deployment. Notice the IPs, because we will identify these IPs as endpoints when we create the service. We create the service by entering the command kubectl create -f nginx nginx-service.yaml. And it says the service is being created, so kubectl get service. And I can see I have now a Nginx service object being created. Type would be cluster IP, the default service type. And it allocates a cluster IP based on the IP pool for cluster IP. So this IP is not yet reachable externally. This is merely being used inside the Kubernetes cluster to group this number of pods. In the next video, we are going to look at service type load balancer, and then we will see that there will be an external IP being created, which we can also access, but that's for another video. We're listening on port 80, and the age is just 9 seconds. So if we now do a kubectl describe service Nginx service, we can see a number of things. First, again, name, the namespace it's being created in, the labels being used based on the spec, and then the type cluster IP, additionally the IP and port, and the target point, and now note the endpoint. So based on the selector app Nginx is able to identify the endpoints, and like I'm showing with the command get pods -o wide, you can see we have .39.40.41 being the endpoints for this service. And it's able to discover that. So let's let's first have a look in NSX-T. So in NSX-T, under the alpha namespace, we would now see a service being created besides the pods being available. So if I click on that object, I can see the service name, and I can see a networking object being created and a label. So the label is obviously the Nginx, and the networking object being created is actually a distributed load balancer server pool. You might see in progress, but that will be green later. So when you click on that cluster IP, you can find the server pool being created. You can see the status is now successful, and it has one virtual server. And the members of this server pool are obviously the pods being created, the pods in the deployments, and grouped based on the selector of the app Nginx. You can see the ports it listens to or forwards to, port 80. So the pods are listening on port 80. And the virtual server will also listen on port 80. And this will be a cluster IP type load balancer. And this is shown as a distributed load balancer in NSX-T. So let's move back to the deployment, and I want to show what happens if we now scale out to 4 replicas. So kubectl apply -f nginx deployment. So now it's reconfiguring the deployment, which means that it now will add another pod for this deployment. Get deployment, nginx deployment. So it's now deploying a new pod. And now it's ready, up to date and available. And let's see what we get from an IP perspective as an endpoint for the pods. So now we see an additional pod with the .35 IP address being allocated to this new pod in the deployment. And let's see if the service should automatically discover that and group at that endpoint in the service. And as you can see, it now has added the .35 port 80 as a target endpoint, as you can see here. Also, going back to NSX-T, back to inventory containers. In the alpha namespace, we now have 4 pods running. And let's zoom a bit deeper into the servers. So looking at the distributed load balancer, we now have 4 members in the server pool. So automatically, this member is being added in NSX-T as well as a server pool member, showing the IP address as well as an endpoint and a listening port. So now this pod is being added to the server pool. So we've scaled out the application, and NSX-T automatically scales out as well. So that's pretty cool. Obviously, before the management plane in NSX-T is being updated on the status of the objects, that can take a while. So now you can see it's successful. So obviously NSX-T object initialization will come after the objects being created in Kubernetes. So keep an eye on that. So that concludes our demo with regards to Kubernetes type service or Kubernetes object services of type ClusterIP. In the next video, we're going to look at service type load balancer and see what's being created in NSX-T. So stay tuned and thanks for watching. Hope you liked it, and until next time. Bye-bye.